Okay, we are doing this little 9-7 video just to make it a little bit more clear about what's happening when we reflect one of our functions. So this is like the challenge problem. It's very similar, I think, to number 15 in your homework, so you can compare this to that one. We've got this function, and I hope it's obvious that that's a square root function, and it's been messed with big time. It's been flipped from our normal direction like that. I've exaggerated the vertical a little bit, but it's been flipped this way, and it's been flipped down, then it's been translated as well. So how do we make sense of that? Well, think about what it means when we have a function like this. Actually, I'm going to think about it if we just have one that we know. Suppose I look at y equals the square root of x. We'll go back to that square root function. If I change the sign inside, y equals the square root of negative x, what this means is every positive x is now made negative. Every negative x is now made positive. So before, if our parent function was like this, now I can't go in the positive direction because there's no way to take the square root of a negative. My function will only show up if I go to the left of the origin and go negative, because then that will switch it to positive and I can take the square root of the positive. So this has the effect of taking this and reflecting it over this vertical y-axis. Changing the x to negative will flip it over the y-axis like that. But if I do this, now all I'm doing is I'm going out to the right x amount, but instead of going up, I do the opposite. I go down. So this will reflect it over the x-axis and make it negative. So I've got a colored marker here. So this is dead, and this one hopefully isn't. So that's the reflection. This is when we have f of negative x, and then this one here reflected like this. This is negative f of x. That's the basic rule. Whatever the function is, it doesn't have to be a square root function. If I take and reverse the sign of the x inside, it switches it over the y-axis. If I take and put the negative sign out in front, it changes that y from being positive to being negative. Okay? So to do this one, I'm actually going to do both things. I'm going to flip it this way, and then I'm going to flip it down. And I can represent this function when it's been flipped twice by the dotted red line here, like this. Okay. Now that's my reflected twice function. So I would say that would be y equals negative x. Okay? That's going to do the double flip. Flip it over the x, over the y, and then flip it down over the x-axis. However, this dotted line has been translated, -3 and -4. So I'm going to just follow my usual rules. Y then is equal to negative square root of, and then it's going to be negative, but instead of x, I'm going to do that translation 3 units in the negative, so I do x plus 3. Moving it down 4 will be just like before. I'm going to move it down 4. So just fill in as you know, and now we're going to solve for a. A is the magnifier that will make sure I hit this bullseye point right there, and I'm going to put the a right there. And I'm going to solve for it. So I take -10, put it in there. I don't know what negative a is, but I do know that inside is minus, and then -12 plus 3. Okay? So now I solve this very carefully. When I solve this, I'm going to just change both of these signs and make them plus. Whoops, and I needed a -4, I'm sorry. -4. I knew there was something missing. That -4 is right there. So now I can change all of these signs, plus, plus, and plus, and then I can subtract 4 from both sides, so I get 6 equals a times the square root of minus, well, that's -9. And minus a -9 is 9, so I take the square root of 9 and I get 3. So 6 equals a times 3. So divide both sides by 3, and 2 equals a. So I go back to my original function, and I'm going to say this is going to be then y equals -2 times a negative x plus 3 minus 4. Okay? Hopefully that's a little bit of a clue as to how you do a difficult problem like that. I'll do one more.